Hello everyone, this is exactly the problem I factorized yesterday. Why am I coming back with the same issue? Well, because almost 95% of the people that commented were all saying, this is wrong, absolutely wrong. You understand? So this is just, by the way, before I come back to this, let me give you a piece of advice. I know there are many people that are willing to join this niche. I would like to let you know that the most difficult niche in content creation is the educational part. Yeah, why? Because I think you are here for your target audience, right? But among these people, there are other people category that are not your target audience. And these people are those that know the subject matter more than you do, and they are classified into two. Because there are those that are waiting for your mistakes just to attack you, and there are other category that will politely correct you whenever you make a mistake. And we love these people. We welcome them. Let many of them come. Then there are other people that do not know the subject matter more than you do, but they can argue from zero to infinity. They don't know it, and they don't know that they don't know. Am I right? So, and the last category, which I started with, are your target audience. They are the reason why you created the channel and pages. So you are here to teach them, and they are here to learn. If you said the right or the wrong thing, they will capture. They will believe in you because they are here to learn. So this is why you have to be very well prepared before you start content creation in this niche. So come back to business. For those that said that the factorization of 6 to the power of x plus 9 to the power of x is not this. That's what we call a check. A check in the sense that you can substitute any value of x in here, evaluate it, and keep the result. Then use the same value of x here. If you get the same numerical values, then it means you are right. So I would like to use 1. So if x is 1, let me say let x be equal to 1. So let me start by plugging it here. 6 to the power of 1 will be 6, right? Because 6 to the power of 1 is 6. And 9 to the power of 1 is still 9. And what is 6 plus 9? 15. So let us plug in 1 here to see whether we are going to get 15 or not. 3 to the power of 1 is 3, multiplied by 2 to the power of 1 is 2, plus 3 to the power of 1 is 3. You can see that 2 plus 3 is 5, and 5 times 3 is 15. 15 equals 15. Therefore, this must be equal to this. And I have seen a lot of comments that were saying, how can we have x outside and still have another x inside? So according to the laws of indices, if you expand back, you have to get 2x at the exponent position, which is very wrong. Remember, both multiplication and division law of indices are only talking about common bases. You can see 3 and 2 are different bases. But well, if you want to confirm, let's expand. I would like to take this and distribute over these 2 times. So you have 3 to the power of x multiplied by 2 to the power of x. Then plus 3 to the power of x again multiplied by 3 to the power of x. For this one, you can see the bases are not the same. But according to one of the laws of indices, it stated that whenever you are multiplying terms of equal exponents, you can multiply their bases and assign a single exponent. This is what I mean. 3 multiplied by 2, then raised to the power of x. And you can take this x back. It will be distributed upon 3 and 2. You have to get the same thing here. But these are common bases. You can take a base and add the exponents. X plus x will give us 2x. 3 times 2 is 6. So this is 6 to the power of x plus 3 to the power of 2x. You can either raise 3 to the power of 2 or 3 to the power of x. It doesn't matter. According to one of the laws of indices, you can always switch the exponents since 2 and x are multiplying. So since this is a number, I would like to use it on 3. 3 to the power of 2 is 9. Then we still have another power of x. Is this not exactly the same with this one? So one thing you should know about factorization, whatever number you bring outside, for instance, if I have 2 outside and inside I have 5 plus maybe 3, okay, something like this, and I want to factorize this. Whatever number you bring outside, make sure you divide the terms inside by that number. For instance, if I bring 2, do I know 5 and 3 have nothing to do with 2, right? But since I decide to bring 2 outside, I have to divide inside by 2. And that's exactly what I have done here. As I have taken 3 to the power of x outside, then I divided the 2 terms inside by 3 to the power of x. The problem will remain balanced, no any change. So this will be 2 multiplied by 5 divided by 2 plus 3 divided by 2. All the same. Once you expand, you have to get your previous 5 plus 3 back. As simple as that.